In today's video, I will show you how to perform basic operations on DynamoDB tables, meaning saving, getting, updating and deleting items on the table. We are going to perform basic operations in DynamoDB tables from Lambda using the AWS SDK. So I will not get into how Dynamo works and what is Dynamo, but I will just go straight into the code and show you how you can get this done. As always, building everything as infrastructure as code from the serverless framework. So let's go to the code. So let's get started as always, making a new directory and getting into the directory. We are calling this serverless Dynamo basic operations. And we get into the directory. Then we just initialize the npm package, npm init-yes, and then we initialize the serverless project, sls create -t aws-node.js-n, and then we put the name of the project so that we don't need to change it in the serverless YAML. It's changed for us. Now we open Atom and we are going to do some modifications, and then we are going to create our Dynamo table. So the first modification, we already have the name in place. I'm going to remove a lot of comments, they're distracting. Then I'm adding my profile because I have many, and I will just use my default profile. And I will pick the region that is Ireland, but you can pick any region you like. By default is North Virginia. Then we are going down in the serverless YAML, and we are just going to define the database using CloudFormation. I have done this many times, and basically we are defining a table and we are using environmental variables. If you want to know more about environmental variables, leave me a comment below and I can make a video out of it. But for now, we are just using environmental variables. And I'm creating them in the serverless YAML so we can access them from the code and from the serverless YAML. So I create a custom variable and then I add my environments property in the provider and refer to these custom settings that we just created. Then the next step is to define permissions for this table, and we are going to define the permissions where the IAM role comment is, and we're replacing it, and we're defining for get to put, update and delete items in this table, so the Lambda can do that. After that, we are going to create some new functions. So I'm going to create one function per each of the things we want to do. You can have everything in one function, or you can have it in separate functions. If you want to know more about this, you can go and check my video on patterns. But for now, I will make it easy and I will make one function per operation. One function for save, one function for get, one function for delete, and one function for update. I'll leave you a card for the pattern video. After we have the 4 functions, I'm just going to save this file and go into the handler. And then here I'm going just to clean up a bit. We are going to create a function that will be generating our response because we are just returning always a status code and a body, so why to repeat that everywhere. And then I'm going to create a new file that it will be the database manager where I will be performing all the operations using the AWS SDK. So I create that file, I go into and I will start defining all the functions. And here is the beef of this video. First thing we want to do is to require the AWS SDK and the module document client. Then I will define the table name as a constant in this module, and that's referring to the variable we have defined in the serverless YAML. Again, environmental variables, if you want to know more, just leave a comment below. I can make a video about this. And then I create the save function, the get function, the delete function and the update function, and you will see that in each of these there is more or less the same structure. There is a parameters variable where we will define different things. In all the cases we have the table name because we need to know in which table we are applying. In the case of save, we have the item, that is the one that we just want to save, the whole item, and the table name. In the case of get and delete, we have the table name and also we have the item ID. That is the reference to this item we want either to get or to delete. And in the case of update, the parameters will be more complex. these parameters will be sent to the AWS SDK, to the Dynamo module. Either we have dynamo.put, dynamo.get, dynamo.delete, dynamo.update, and they will all take the parameters. I'm always promisifying these calls, so this is a promise. So I'm doing .promise after all of these calls. For the update, let's stop for a moment and analyze the whole thing, because I think it's the most complex of all of them. So the update, it takes 3 parameters, the item ID, a parameter's name, parameter's value, and then it returns the new modify item. So the parameters that we need to construct this variable called parameters, the table name, as in the other cases, the key, that is the item ID, and then it will take set of other things. First, it will take a condition expression. This is not necessary, but I like to add it in the case. So if the attribute exists with this item ID, we can continue. If not, it will throw an error. The update expression. And here we define what is the parameters that we want to change. What is the attribute in the table we want to change? In this case, it's a flexible one, it's dynamic. So we pass that in the method, and I will put set params name, that will be whatever we decide to pass in this method, and it will be setting it to some value. The value is also dynamic, and you can find it in the expression attribute values that we define the dynamic value. And then we have the return values that we want to return all the new. You can change these for other options, either the old and all, new and old as well. You can check the documentation for the AWS SDK. I will link it in the comment box below for you to check. And then after we have these 4 operations, so we can go back to our handler and do the calls that we want to do from these operations. So we are going to create our 4 methods that are going to handle these functions. First, we want to generate the item ID. So for that, we need to use this library called UUID. So we just install it in our dependencies, and then we can use it. I will use that in the save. So we have a dynamic item ID whenever we save, because in Dynamo, items needs to be identified with a unique ID, so we should not have duplicates. So now I have the save item, and I will just fetch the item body that it will be passed in the API gateway body, in the request body, and then I'm attaching to that item that we get from the body the item ID that we are generating with this library, and then I'm passing that item to the database manager, that save item, and I'm returning in the callback the response with this item ID we just created and the 200. For the get item is similar. We are getting the item ID for the path parameters, and then we are passing that item ID to the database manager to the get item. And this item that we get, I'm returning it in the response to the API gateway so the client can see it. For delete, we have a similar one. We are getting the item ID from the path parameters, but we are just returning the item was deleted, because the response in this case will be empty if everything goes fine. And here we are not handling errors, so in the case that the item is not fine, we are just not doing a catch. So that's something you need to handle in your case. For example, if you get an item that doesn't exist, it will return you an empty response because we are not handling the errors. So remember that these are only for the happy path, but this is an example for you to see. And for the update, it's a little bit more complex. We are getting the item ID from the path parameters, and then the param name and the param value from the body, because this will be a put, so we will have a body. And then we are passing those 3 things to our update item that will return the new item updated, and we will pass that back to our response. And that's all the code we need. Now we can go and deploy, and after this deploy we can test it in Postman. So I will speed this up for you, so we go to testing. So when this is deployed, we get our 4 endpoints that are more or less the same. They just have different methods, and then we can take them to Postman and start playing with them. So we put our first one, that is the post, and we create a body that is very flexible because we have not defined anything. So we just pass whatever we want. I just pass a name, for example, and then we can pass some attribute 1, attribute 2, and things like that. This is an example, so it's not important what is in the item. Just imagine that you have something that makes sense for you. And then after we have this body, we can just send it and we will get an ID back. This ID we can use in the get. So we can now run the get. That is the same URL, but it has just a path parameter at the end. That is this ID that we just got. So I modify the call and I send it, and then we get the item back with the ID and all the attributes. We can update this item and we are going to change some attribute. For example, attribute 1. We are going to change and we are passing a new value for that attribute. And then we send it, and then we will see that the response now has this attribute 1 to be attribute 1 underscore new. So that changed. If we do a get again of this, we'll get exactly the same because this was saved in the database. Now we can do delete. If we just do delete, then the item was deleted, and then if we do a get, we are going to get an empty response because this is returning from the database an error and we are not handling errors. So the code, as always, is available in GitHub for you to take a look. That was the video for today. I hope you like it. If you did, give a big thumbs up. If you have any questions, comments, requests, you can always leave it in the comment box below.